Let us talk about AWS Redshift architecture at high level. Redshift architecture contains following key components: the cluster, storage, and internal networking. Within cluster, we have a leader node, one or more compute nodes, and each compute node is partitioned into a number of node slices. Cluster is core of an Amazon Redshift. It contains a leader node, one or more compute node. The leader node coordinates between the client applications and the compute node. Client applications interact directly only with the leader node. The compute nodes are transparent to the external applications, which means external applications will never have access to the compute node directly. The leader node manages the communication with the client applications and the compute node. It parses the SQL and develops the query execution plan. So leader node compiles the code and distributes the code to the compute node. It receives the intermediate results from the compute node and aggregates it and shares the final results with client application. The compute node receives the compiled code from the leader node and run the compiled code, prepare the intermediate results, and share it back to the leader node. Each compute node has its own CPU and memory depending upon its node type. So compute capacity of a Redshift cluster can be increased by adding more compute nodes or upgrading the node type of a compute node or by both. So what's node slices? So each compute node is partitioned into node slices. Each slice is allocated with a portion of the node's memory and storage. The leader node manages distributing the data into those node slices. And it also distributes the workloads accordingly for the parallel processing. If the distribution key is specified during the table creation, the data is distributed to the node slices based on the key. So it is important to specify the proper distribution key during the table creation to take advantage of Redshift parallel processing. So next component is storage. So data warehouse data or a user data is stored in a separate storage tier called Redshift Managed Storage. It provides an ability to scale the internal storage to petabytes using the S3 storage. It also provides an ability to scale the storage and compute independently. It uses high performance SSD based caching. It implements various optimizations based on the data block temperature, block age, and workload patterns to deliver high performance on top of S3 hosted data. So next component of an AWS Redshift architecture is an internal network. So AWS Redshift takes an advantage of AWS high-speed internal networking to communicate between the leader node and compute nodes. The compute nodes run on dedicated or isolated network that the client applications will never have direct access for security purposes. So that sums up all of the key components of AWS Redshift architecture. Hope this video was useful. We will be talking more of this in upcoming videos. Thanks for watching.